Okay, so in this video we're starting section 6.2. So in 6.1 we introduced what are called traveling salesperson problems, where we want to visit sites and then visit each site once. Well, a site corresponds to a vertex. So we're going to look at Hamilton paths and Hamilton circuits. Now we've been looking at Euler paths and Euler circuits. So remember that the Euler paths and circuits go down every edge once and only once. When we're looking at Hamilton, we're not concerned with edges, we're concerned with vertices. So it's going to be a path in a connected graph that visits all of the vertices of the graph once and only once. Some edges may not be crossed. Okay, same thing for this. It's a Hamilton circuit that visits all of the vertices once and only once. So if we compare what we've been doing, which is Euler, to Hamilton, for Euler, we cannot travel an edge more than once. Okay, remember we had to cover every edge. Okay, so that was the trick with Euler, is to go down every single street. And in Euler, it didn't matter if we went through a vertex more than once. So we can visit a vertex more than once. So Euler paths and circuits, those are solutions to street routing problems. Hamilton paths and circuits are going to be solutions to traveling salesperson problems. So they're very concerned with vertices. Now the first one is the same as it is over here. We still cannot travel an edge more than once. But this one's going to be different. In Euler, we want to cover every edge. And in Hamilton, we may not cover every edge. Now what we do have to do is we have to visit every vertex. And we cannot visit a vertex more than once. Okay, so notice here, Euler, we cover every edge. Hamilton, we cover every vertex. Euler, we can visit a vertex more than once. And in Hamilton, we cannot. Now, the only exception to this is in a circuit, except where we start and end, because we do have to basically go back home, right? If we think of our starting vertex as home, we're going to visit all these places and then we're going to go back home. All right, so a Hamilton circuit is defined by the order of the vertices and does not depend on which vertex is the starting or ending vertex. So this is kind of interesting because when you write a circuit, let's say your circuit is A, B, C, D, A. Okay, so we go from A to B, B to C, C to D, D back to A. This is going to be the same as, let's say we start at C. So we're going to go C, then D, then A. We're going to come back to the beginning. We're not going to write A again, but we're going to write B and then go back home to C. Those are considered to be one circuit because they do travel the same path that goes in the same order. All right, so when we're looking at graphs, we'll see that some have neither Hamilton circuits nor Hamilton paths. Some graphs will have Hamilton paths, but not circuits. Circuits are a little harder to find. Any graph that has a Hamilton circuit will have a Hamilton path. That should have an A. Because we can just take the circuit and make it into a path by deleting an edge. Okay, but there are other ways to get Hamilton paths other than finding a circuit and deleting an edge. That's what this bullet point is saying. And then Hamilton circuits and paths can be reversed, which gives you a different circuit or path. So that's a handy trick to have if you're asked to find two on your homework. You can find one and then reverse it to get a second one. All right, so let's look at the second page where we have some examples. So here is our graph. We want to find one Hamilton circuit. Okay, so let's just go ahead and start at A. So these are easier than Euler because all we want to do is visit every vertex once. So from here we have a couple of directions we could go. We might want to go down to G, or we might want to go over to B. So there's more than one possible answer here. So let's just say I go to B. So I'm going to go A to B. So I visited A, I visited B. Maybe I go down to D and then up to C. So now I visited D and C. So remember, I'm trying to visit every vertex. So then I can just come down to E, come across to F, come across to G, and then go back home. So notice I didn't travel all the edges. If I go ahead and trace that, this was my circuit. So I went 1, 2, 3, 4, 5, 6, 7. So notice I didn't do any of the lines in the middle, but I did visit every vertex, and that's all that matters for Hamilton. So they are generally much easier to find. Now I'm asked to find a path that starts at A and ends at B. So I want to visit every vertex and then stop at B. So I would probably go this way first. I would go A to G, and then maybe just come across the bottom and do F to E. So I visited A, G, F, E. I'm going to come up to C. Now remember, I'm saving B for last, so I'm going to go D and then B. So notice for a path, we start and end at different letters. For a circuit, we start and end at the same letter. Next, I want to find a path that starts at D and ends at F. So I want to start here. Okay, so let's see, maybe I come up to C. So I'm going to go D, C, and this isn't the only answer. Let's see, I eventually want to end at F. Let's go ahead and come down to E. I want to stay away from F, but I could come back up to B. So I've done D to C to E to B. Let's go over and visit, let's see, where do we want to go next? Let's go down to G, because if I go to A and then G, I can't get back to D. Or well, I guess I could do that. Hold on. I'm ending at F, so D, C, E, B. I could go A, G, F. That would work. All right, so sorry, I was thinking it was a circuit instead of a path. All right, so we visit every single vertex, and it doesn't matter if we visit every single edge. All right, so let's look at another example. For this one, we want to find a path that starts at A and ends at E. So I'm going to start at A and I want to end at E. So let's just say I go up to F first. So I'm going to go A to F. From there, the only place I can go is B. So I've been to these three. I want to stay away from E right now, so maybe just go around the bottom and go C, G, D, and then back to E. So A to F to B to C to G to D to E. So I touched every vertex. Now notice the next one says find a Hamilton circuit that starts at A and ends with edge EA. So that means my last edge has to go from E to A. So I could steal this path that I already found. I'm going to bring all of that down. So remember, that visited every single vertex and ended at E, so then to make it a circuit, I just go back home. So I can just stick an A on the end. So remember, when you're checking Hamilton, you should see all of your letters once and only once, unless it's a circuit, and then of course the beginning and the end have to match. All right, so let's do a path that starts at A and ends at C. If you want, you can pause the video and try to come up with your own. I'm kind of thinking about going around F to B and then going down here to D and back up to C. So remember, the rule is I have to visit every single vertex. So A, F, B, I'm going to stay away from C, so I'm going to go E, D, G, and then back up to C. All right, and then my last one, I want to find a path. There are a lot of different answers for this one, by the way, so yours may not look like mine. I want to start at F and I want to end at G and visit every vertex in between. So pause the video, come up with a path, and then come back and we'll talk about some different possibilities. All right, so I'm going to write a couple of these up here. Hopefully you paused it and went ahead and got you a path. So remember, we have to visit every single vertex. These are just a few options. I don't even think I'm listing them all. These are just some of the ones that we came up with in a previous class. So all of them start at F, end at G, and visit every single vertex. You can see on these many times there's a lot of correct answers, and it's generally not too bad to find a Hamilton path.